Hi and welcome back. Now in this chapter we are going to look at the decentralized AWS data options. Now when it comes to application, so in our demo application which we saw earlier in the earlier video, let's imagine that we have two services. So we have our price service and our order service. Now if the services are connecting to backends to collect data, then it is important from an architecture pattern for microservices to even have a separation of concern for the database as well. So the design practice is to have a separate data store for each service. So in our example, we are going to create two data stores. Actually, I've already gone ahead and created them. Now, I don't have one data store with two tables. Remember, these are two separate data stores. So in my example, I have two MySQL databases. So there are a lot of options available from AWS. You can use MySQL, you can use Oracle, you can use PostgreSQL. You can also use the NoSQL database such as DynamoDB, or you can even use Amazon Aurora. So there are different options available for you, but in the end, the idea is, I said, to split the data store so that each service connects to a separate backend data. So now let's go on to the AWS console. I just want to show you what I've done, how I've changed the code, how I have separate backend data stores for my price and orders.php. So here I am in the AWS console. Now I'm on my relational database section. Now what I've gone ahead and done is that I have created two databases. So these are two instances. They're both running on the MySQL engine. Both of these databases have separate endpoints. Now I'm just going to go ahead and connect to these endpoints from my command prompt. So I'm just going to connect to one of the database instances. So I'm connected through. So if I look at the databases, I have one price database. So this is from my price.php page. And in this database, I have one table, that's a price app table. And if you look at the price app table, I've actually put in a simple table which has a name. So the individual items which are displayed on my demo app.php page. And then I have a unit price for each of these items. So in this table, in this database, now similarly in the other database, so if I go back to the console, so if I go back to my instances, so in my demo DB, I have the data for the quantity, right? So I have two separate data stores in place. Now I'll just quickly show you the code of one of the pages. So this is the code for my orders. So now I'm not simply sending static data back to my main presentation layer. What I'm doing now, I'm actually connecting to my data store and then getting the quantity for each of the items. And then that is actually going on to my presentation layer. And if I go back to my presentation layer, if I do a refresh, so I've actually copied this code onto the server, I will get the same exact output. But what I've done in the backend is that I have actually changed each of the pages. It's not affected my main application. I have connected each of these PHP pages to a backend data store, and note, each of these data stores is separate areas of concern, a best practice from a microservices based architecture. So I did mention that you could use different data stores. Just to make my example or our example much simpler for you to understand, I have two separate MySQL databases. So you could use a plethora of databases which is available from AWS. You could use Oracle, PostgreSQL, or even use DynamoDB. And if you want to use, you could use a cluster of these databases as well. In the end, the idea is to have a different data store for each of your services. Now let's go on to our next video, which is the AWS Elastic Beanstalk service.